Hello students, how was your night? Now we continue the lecture on power transmission. In the last class we considered gearing. Now we'll be considering belt. Relax and enjoy the lecture. The objective for this class are to identify the different types of belt drives, to identify the types of belt, the formula for the length of an open belt drive, and the formula for the length of a cross belt drive, and the formula for power transmitted by a belt. Introduction. Belts are used to transmit power from one shaft to another by means of a pulley which rotates at the same speed or at different speed. The amount of power transmitted depends upon the following factors: the velocity of the belt, the tension upon which the belt is placed on the pulley, the arc of contact between the belt and the smaller pulley, the condition under which the belt is used. Types of belt drive: light, medium, and heavy. The power required will determine the type of belt drive to be used. Types of belt: we have the flat belt, the V belt, and the circular belt. Material used for belt: leather, cotton, and rubber. Types of flat belt drive: we have the open belt drive and the cross belt drive. Now we have the open belt drive. As you can see in the diagram, we have the driver and the driven. The top is always the slack side and the down is the tight side. What you need to know about the open belt drive is if the driver is going clockwise, the driven also go in the same direction, which is clockwise. If the driver goes anti-clockwise, the driven as well go in the anti-clockwise direction. And power is being transmitted, as you can see, by the belt from one pulley to the other. Now we have the cross belt drive. As you can see, this is the driver while the other side is the driven. The top is always the slack side and the down is the tight side. As we can see, if the driver is going clockwise, the driven is going in the anti-clockwise direction. Why, if the driver is going in the anti-clockwise direction, the driven goes in the clockwise direction, and power is being transmitted from one pulley to the other by the means of the belt. The velocity ratio of a belt drive is N2 all over N1 is equals to D1 all over D2, where N stands for the speed of revolution and the D stands for the diameter of the pulley given. Speed of a belt. Let's say we are given x1 as the slip between the driver and the driven, and x are the slip between the belt and the follower. Now the slip of a belt tends to reduce the speed which is transmitted. As we can see in the formula for the speed ratio, the effect of the slip has been considered by adding the x1 plus x2. The length of an open belt drive, as we can see in the formula given on the board, where R1 is the radius of the big pulley and R2 is the radius of the smaller pulley, while X is the distance between the center of the two pulleys. As you can see in the formula, that L is equals to pi R1 plus R2 bracket close plus 2s plus bracket open R1 minus R2 bracket close all square all over X. The length of a cross belt drive. As you can see, that it's almost similar to the length of an open belt drive, but the only difference is that in the case of the minus we have the plus, so we should take conversant of these, that we have a plus there, just like an open belt drive. Power transmitted by a belt. The formula for the power transmitted by a belt is P is equals to T1 minus T2 multiplied by the velocity, where T1 is the tension on the tight side and T2 is the tension on the slack side, and V is the velocity of the belt. In this lesson, we have learned the different types of belt drives, the types of belt, the formula for the length of an open belt drive, the formula for the length of a cross belt drive, and the formula for power transmitted by a belt.